Hi everyone. We're going to do a couple of more limiting reactant problems in this video. And in this problem, they gave us a balanced chemical equation, and you may remember this as the Haber process. And then they gave us this picture, and they're saying that each model represents 1 mole of the substance. So this is 1 mole of hydrogen. This is 1 mole of nitrogen, N2. And this would be 1 mole of product, NH3 or ammonia. Show the number of moles of the product and the excess reagent left after the complete reaction. So this is our initial, and then this is what we're supposed to fill in for the final. So I think the first thing we ought to do is determine the limiting reactant. So is it going to be hydrogen or nitrogen that limits us? So I am counting here 1, 2, 3, 4, 5, 6, 7, 10 moles of hydrogen. And if hydrogen is the limiting reactant, for every 3 moles of hydrogen, we could get 2 moles of product, ammonia. And I think that's something like 6 point, and I'm going to consider this zero significant. So 6.67 moles of ammonia produced if hydrogen is a limiting reactant. Let me test the other reactant, and I'm counting 3 moles of nitrogen. And for every 1 mole of nitrogen, I can make 2 moles of ammonia or product. So now I'm getting 6 moles of ammonia. So now I know that I'm going to have to draw 6 moles of ammonia in this box, and I know that nitrogen is the limiting reactant, which means there will not be any nitrogen left over, and hydrogen is the excess reactant. So I think what I'll do is figure out how many moles of the excess reactant left. Well, that'll be the ER initial minus the ER reacted or used. So the initial moles of hydrogen that we have here are 10. And then to figure out how many moles of hydrogen reacted, we have to start with the limiting reactant. So again, we had 3 moles of nitrogen. And for every 1 mole of nitrogen, we're going to use 3 moles of hydrogen. So that'll be 10 moles of hydrogen initially minus 3 times 3 is 9 moles of hydrogen that reacted. So we only have 1 mole of hydrogen left. So I'm going to sketch. That's the 1 mole of hydrogen left. And now I'm going to go ahead and sketch the 6 moles of ammonia. And ammonia again is NH3. I'm going to draw my 6 nitrogens. And then now I'm going to add the 3 hydrogens to every single one of these nitrogens. And that's it. So again, I'm not going to put any nitrogen in our final conditions because it was the limiting reactant. It all got used up. We've sketched in our 6 moles of ammonia that were produced, and we've sketched our 1 mole of hydrogen left. And if I were you, I would pause the video and I would make sure and count that do, that the number of moles of hydrogen atoms, so we have 10 moles of hydrogen molecules, which would be 20 moles of hydrogen atoms. Take a minute and count. Do you have 20 moles of H atoms on the right? And I think we do. We have 18 from the ammonia, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That agrees with what you had on the left. And then for the nitrogen, we have 1, 2, 3, 4, 5, 6, 6 moles of N atoms, and you definitely can see those 6 moles of N atoms on the right. So that just illustrates the conservation of mass. We'll do one more limiting reactant problem. So we have a balanced chemical equation, and they tell us that we have 0.86 moles of this manganese 4 oxide and 48.2 grams of HCl. They want to know which reagent will be used up first. Well, in other words, they want to know what is the limiting reagent, and then they also want to know how many grams of chlorine are produced. So let's figure out the limiting reactant. And you know how I like to do it. I like to see which reactant gives me less product. And for some odd reason, they gave us the moles of manganese 4 oxide, and they gave us HCl in grams, but we can make that work. So 0.86 moles of manganese 4 oxide, and for every 1 mole of that manganese 4 oxide, I can get 1 mole of chlorine. And ultimately, they want the answer in grams, so I'll go ahead and find the molar mass of Cl2. For every 1 mole of chlorine, that is 70.906 grams of chlorine. So if manganese 4 oxide is the limiting reactant, we could make 60 with an insignificant 979 grams of chlorine, but I have to test the other reactant, and that's HCl, which they gave us in grams. So 48.2 grams of HCl. I have to convert to moles. So the molar mass of HCl is 36.461 grams of HCl in 1 mole of HCl. And now we go to our equation. For every 4 moles of HCl, we can make 1 mole of chlorine. And let's go all the way to grams. For every 1 mole of chlorine, there's 70.906 grams of chlorine, since that's what they wanted anyway. So let's do the arithmetic here. And I am getting a smaller number than 60. I'm getting 23.4 grams of chlorine. So immediately we know that HCl is limiting, manganese 4 oxide is the excess. So we've answered already the question. Which reagent will be used up first? The limiting reagent, that's HCl. And how many grams of chlorine? This is how many. Now, even though they didn't ask us, why don't we see if we can calculate how many grams of the excess reactant we have left over? So that's not going to be hard. So maybe we can start off working in moles. The moles of ER left are going to be the initial moles minus the moles of the excess reactant used. So what we had initially is the 0.86. And then how do we figure out the moles of manganese 4 oxide used? It depends on the limiting reactant. And we had 48.2 grams of that limiting reactant. So let's convert that to moles. For every 36.461 grams of HCl, that's 1 mole of HCl. And now use your balanced equation. For every 4 moles of HCl, 1 mole of manganese 4 oxide was used. So this is 0.86 moles initial. Let's calculate the moles of manganese 4 oxide used. I am getting 0.330 with an insignificant 49 moles of that manganese 4 oxide used. So what we have left, and again, I'm only going to need 2 decimal places here. I am getting 0.52 with an insignificant 95 moles of manganese 4 oxide left. And maybe I'll convert that into grams. For every 1 mole of manganese 4 oxide, I have, if I can calculate the molar mass, 86.937. So that would be 46 grams of that manganese 4 oxide left. So I know the problem didn't ask us to do this, but I just thought it would be good practice. Hope you enjoyed the video and thanks for listening.